This is the question of paper 3, May 2024, time zone 1. For this question, we're going to need some statistical tests. Statistical tests that we need to know are here in this list. We're going to need some of these statistical tests. The purpose of this question is to help a company decide whether or not they should use a new technique to make components. Factory produces components for a tractor. They have designed a new technique to produce one of the components that they hope will increase its useful lifespan. They test 120 components made with the new technique and 240 with the technique they currently use. At the end of 250 hours of use, they check the components and record whether they have no cracks, minor cracks, major cracks. The data from the trial are given in the table. In total, 141 components had no cracks, so that the value of A is 53. 141, no cracks. So in the first row, so the only thing we need to do here is to find A is to do 141 minus 88, which is 53. That's the only thing we need to show. The value of B, then we need to know that for the new technique, the total, it's given in the question 120 with the new technique. So to find B, we get 53 and add to 54, and this is 107, and then 120 minus 107, this is 13. So 13 major cracks. So the value of B is 13. Letter B, given that these components had minor cracks, find the probability that it was produced by the new technique. Here it says that it had minor cracks. So we are reducing the sample space from the total of 360 to only 150. That's the total that had minor cracks. So from those that had minor cracks, the probability that it was produced by the new technique, 54 out of these 150 is the probability required. So the total is 150. From these 150, 54 were produced by the new technique. You could leave the answer as a fraction or change this to a decimal to become 0.36. We could also use the conditional probability formula, which is probability of A given B is probability of A given B divided by the probability of B. In this case, the events A and B would be A, the probability it was produced by the new technique, given that it has minor cracks. So if we want to use this formula to solve this question, then we'd have to find the probability of being new and had minor cracks divided by the probability of having minor cracks. Then we'll take this from the table. The probability of having minor cracks, it is 150 out of the overall total 360. So 150 out of 360. And probability of being new and had minor cracks, 54 out of 360 as well. So the probability would be the same as found previously. So 54 out of 150. This would be the same result, but a different way of getting this. C, a chi-square test for independence is performed at the 5% significance level to determine whether a component having no cracks, minor cracks, and major cracks is independent of the production technique used. State null and alternative hypothesis. For this type of test, chi-square test of independence, null and alternative hypothesis must be statements. For the null hypothesis, a statement using the word independent. And this sentence helps us to write this null hypothesis. So it could be development of cracks, or is independent of technique used. And then the alternative is technique used. And the alternative hypothesis, H1, it's the same sentence, but the negation of the sentence. Development of cracks is independent. Is not independent, sorry. It's not independent of the technique used. So the same sentence. To find the p-value, we need to get the table and then place this table now with all values, accepting the totals in our calculators. First, I'm going to find the p-value using Texas calculator. In Texas calculator, we need to go to matrix, select one of the matrices, matrix A, let's say, to add it. So matrix A, we want this matrix to be, in this case, a 3x2 matrix. We want 3 rows, 2 columns, 53 and 53, then 88, 54, 96, 13, 56. After that, we go to statistics, and then we go to tests, and then we go to chi-square test, not GOF, just chi-square test. That's the chi-square test of independence. So the calculator is going to get information from matrix A, is going to store the expected values in matrix B. Then we press enter to get the p-value 0.0 to 3 significant figures 0.0170. So just take this value from the calculator and write this down correct to 3 significant figures. P-value is equal to 0.0170. And then the conclusion of the test is using the same, the normal decision rule, we would reject the null hypothesis if the p-value is smaller than the significance level, which is 5%, since 0.0170 is less than 0.05. So we have enough evidence to reject 80. And then we have to just add that because it says state the conclusion in context. So we're saying that there is evidence to reject 0, so it's not independent. And developing cracks or not, developing cracks or not is not independent. Is not independent of technique. The same calculation could be done in Casio calculator. In Casio calculator, we could go directly to statistics, menu number 2, statistics. Then we go to go back to tests, and then we select chi-square test, and then we select two-way for the chi-square test of independence. And then if we need to, we need to put the matrix in calculator. So we go to matrix A, and then we're gonna edit this matrix. So we place the numbers, but not, we have to change the number of columns. So here we want just 2 columns, delete one of the columns, get the table, 53, 88, 54, 96, 13, and 56. And then we exit. We go back here, and then we just execute. We're going to get the same value we found in Texas, same p-value, and obviously the same conclusion is that we now have enough evidence because this value is smaller than 5%. Letter D, for the components in the trial that were made with the current technique, show that the proportion with developed cracks is 19 out of 30. Going to the table, the current technique, there is a total of 240, and 88 plus 96, 96 plus 56 developed cracks, minor or major, or 88 did not develop cracks. So we could find this in different ways. One way would be 240 minus 88, and then divide this by 240. Then you could use the calculator to get this value. So let's use the calculator to find this. 240 minus 88 over 240. This number, which as a fraction is 19 over 30. As an alternative measure, the researchers decide to let P be the probability that a component made with the new technique develops cracks. They then test the following hypothesis. In a random sample, in a randomly select sample of 120 components made with the new technique, let X be the number which developed cracks. The researchers assume that under the new hypothesis, X follows a binomial distribution with 120, 19 out of 30. State one additional assumption that researchers are making in choosing this distribution. As usual, in situations like this, in statistical tests, in confidence intervals, when selecting the objects, in this case, components, we have to do the selection independently, one from the other. So that's what we have to state here. That's what says in the mark scheme. The probability of each component developing cracks is independent of all other components in the sample. The key word here is independent. Selection is independent. Also, the development of cracks can be partitioned into clear groups, minor and major, but the most common situation is stating that the selection is independent. So for letter F, use appropriate data from the trial to perform the test proposed by the researchers at the 5% significance level. State the conclusion of the test, justifying your answer. In this question, we are using statistical tests. We have already used in the first part the chi-square test of independence. Now, we are using this hypothesis test for population proportion using the binomial. This is not one of the tests in the menu tests of the calculator. We need to use the binomial distribution to find the p-value. So the hypotheses are already stated, and then we need to use the fact that we are using the new technique. And in the new technique, with 120 trials, we go to the table to get the value, the probability of getting any type of cracks, which is 54 plus 13. So the observed value in this case is that we had 67 cracks out of 120. So for this test, we need to get this value, 67, and find the probability that the variable X is less than or equal to 67. Using the distribution binomial, 120 trials, and probability 19 out of 30. Then we go to the calculator to get this value, and then to compare this value later with the significance level. We go to distribution in Texas and go cumulative, binomial cumulative, and then 120 trials, a probability of 19 out of 30. The X value is 67. Let's see what value. So 0.0549. 0.0549. That's our p-value. Using our Casio, we go to the calculator. We could go, for example, to distribution, go to menu binomial, and then select this tail. Then we select the X value 67, number of trials 120, probability 19 out of 30, and then execute. We get the same value that we found with Texas. And then the conclusion of the test is that since this value is greater than 0.05, we do not have enough evidence, so not enough evidence to reject H0. So not enough evidence to reject the null hypothesis. And then we cannot say that the proportion has decreased. It's still 19 out of 30. And if it were a little bit more than 67, if it were 68, then the probability would probably be less than 0.005. When we find this value, we compare with the p-value, but we could also find the critical region. And to find the critical region, we check some other values. Just like I said, if we put 68 here, or sorry, not 68, 66, then this value is the first integer for which the probability is smaller than 0.005, and then the critical region would be less than 66. So, but in this case, it's easier just to find the probability with the observed value, and then compare this value with the significance level. Then, in comparison with the test in part C, state one mathematical reason why the test in part F might be preferred. The test in part F might not be preferred. So here is a question of interpretation. The Max scheme says that for this thing, so the answers we found were correct, and then what is it? This here. The test is for proportion is directional. I've never seen this word before. And so considers whether the new treatment reduces the number of components developing cracks. And so that would be a reason for parts A1 to why parts F might be preferred. This one with the binomial distribution. The test is directional. So considers whether the new treatment reduces the number of components. Not so clear for me, being very honest. Either for part 2, why we could consider this not be preferred. There could be a variation in the value of P chosen for the null hypothesis. The value of P from the sample might not be a representative of the current technique. The testing F does not treat minor and major cracks as different attributes. The testing C does not treat minor and major cracks as different attributes. Still, another option is that it has to make an additional assumption, for example, independence, just like in the other case when we mentioned that the selection should be independent. Many ideas that could be used for other statistical tests, because statistical tests are not like always, the conclusion of the test may be not realistic. For these components, the researchers also consider the mean time taken to cracks developed. It's hoped that using the new technique will increase this value, A second trial is carried out, and the times in hours taken for cracks to appear is recorded. The mean time taken for cracks to appear, T-bar, and the standard deviations of the samples for each technique are given in the following table. Perform an appropriate test, 5%, where the new technique increases the mean time. The hypotheses in this case are mu1, the mean of the first, is equal to the mean of the second group. So the mean of new technique is equal to the mean of the current technique. And supposedly it would be necessary to state what's mu1. It's the mean time for new technique, mean lifetime. It's lifetime. Not lifetime. It's mean time taken for cracks to appear. Mean time taken for cracks to appear in new technique. And mu2 is the mean time taken for current. So just a clear difference between the two, what is mu1, what's mu2, and the null hypothesis, the alternative hypothesis is that since it increases, the alternative hypothesis that the mu1 new technique, the time taken is greater than for the current technique. So we have to state this and insert information in the calculators and get the p-value. We get the calculator. Let's start with Texas. We go to the test, which is statistics tests, and then we select the two sample t-test, and then in two sample t-test, we go to statistics, insert the information, and then we change here the alternative hypothesis to greater than mu1 is greater than mu2. Hold should be yes, and then calculate. So the p-value 0.0162, p-value 0.0162, which is smaller than the significance level. So enough evidence to state that to reject the null hypothesis, reject A20. So in fact, the new technique increased the mean time taken for to get to see a crack. And in Casio, we go to the menu statistics, and then to get to the test, we go to tests, and then t-test, and then two sample t-tests. And then we change here the alternative hypothesis to greater than, insert the values in the calculator. If they are not there, of course, they are not be there. We're going to insert this, and then put on, and then execute. That's the same, and we get the same value, right? The company decides to go ahead with the new technique and publishes the following statement: statistical tests show that the new technique will significantly increase the time before components crack and need to be replaced. Comment on this statement. The result of the test says that, yes, the mean time has increased. But when we look at the values, it has increased significantly according to the test, but not by so much, like from 249 to 250, an increase of 1 hour only. So we would say, okay, this is an increase, right? But not by so much, by not so much. The Max scheme says, though statistically significant, the new technique only seems to increase the time before cracks appear by 1 hour out of 250. So this is not a significant increase. That's another option here, but that's like the main idea of the question is that, okay, you have to say, okay, it has increased, but the increase is very small.